All right, so thank you everybody for joining today. My name is Nicole Dyer, and I am the Architectural Services Consultant in the DC, Maryland, and Northern Virginia region. Thank you so much to Sue and Pam at AIA Potomac Valley for helping to coordinate this event with me today. I love teaching, and so every opportunity I have to share, I'm always looking for, so really excited about that. So before we get started into the program today, which is about touchless openings, just a couple of quick slides about what I offer, what Allegion offers as support to our architects. So hardware specifications, hardware sets, and numerical door indexes are something that we provide for you when you're looking for a specification for Division 8. Catalog cuts are part of that. Usually there's a live link within the documents themselves. Product substitutions and requests or requests for approval, whether or not these are things that are going on during the design process or during the estimating process, sometime as things have been contracts have been awarded and they're going through submittals or construction and questions come up about applications or conflicts. We're here for you to support that. It's always our goal to create a specification for you as true consultants that's appropriate to the project, both as far as application goes and code compliance. But in addition to that, that it's got the budget concerns in mind that everyone needs in order to keep the project on track. Occasionally, sorry, that thing flipped all by itself. Occasionally, I think we all know that value engineering comes into play, and we can help support in that case so that we get the functionality and co-compliance we need. But if there is room for wiggling as far as product selection, we can help out with that. Hardware submittal and review is a very important part of the process. Usually the one thing that makes architects more uncomfortable than the specification in the first place for hardware is the point at which the submittals come back through and you need to evaluate them to see if they comply. And we are happy to take that off your plate as well. Two reasons. First of all, we want to support you in that way. And second of all, our goal is as a manufacturer to position our products on a project when it's the right thing to do. And so we want to make sure that that's being followed through on. And finally, as far as product options and conflicts go, especially when you're looking at a project with access control and electrified hardware, because again, mechanical hardware is complicated enough. When you add a battery or a wire to it, it gets even more exciting. So we're here to help coordinate that process from the design point forward. And these are just some resources that Allegion offers. First, through our commercial website, there is an architectural page selection for you to click on to have access to different documents and links. idighardware.com. If you're not familiar with Lori Green, who does happen to be an employee of Allegion, but she is much more than that as far as an industry source and an advocate, especially for code compliance, hardware applications. If you ever have questions, her website is an amazing resource, and you can email her and she will reply. She is just full of passion and dedication for the hardware industry. So great resource. We have an architectural newsletter also, support the typical literature sources, suites, and RCAT, BSD. We are a CSI corporate sponsor and an AIA corporate sponsor, and that's very important to us. The teaching process, sharing, and doing it in a compliant manner is absolutely part of our goal. One of our values is doing the right thing, and that this teaching process is part of that. So without further ado, we will dive into our program today. So this is the requisite AIA slide regarding the endorsement and creation of this this presentation and the fact that it is copyrighted. Sue did mention when we began that this session is being recorded and it will be available through the AIA-PB website for their library, which is great. I'm absolutely thrilled about that piece. So I'm not going to read every word on this program description slide. I think we've all joined in for a great reason. And the title, the theme for the day is Touchless Openings, When, Where, and Code Consideration. So, and Sue, my dog is not behaving, so sorry about that. And these are things that we'll be able to be much more confident about at the end of this process. Just so you know, part of our responsibility when we're doing these virtual presentations is to conduct a couple of polls during the session. And what I would ask you to do when these poll questions come up is either to unmute yourself and say something or to drop something into the chat box for us. And it's difficult for me to see that, but Sue is going to keep an eye for me. So the first one is popping up right now. So what types of openings can benefit from touchless solutions? Anybody have any suggestions about openings in general that would be a good application for a touchless opening? Any ideas? Oh, there's
We've got doors coming up, sterile environments in a healthcare setting, accessible doors, doors at grocery carts, doors to restrooms, motion sensor.
Okay, all kinds of great answers. That's awesome. Yes, absolutely.
Public restrooms coming up a lot.
Yes, it's a very good one. I think we all know, especially from the advent of COVID and how it's changed our lives and has in many ways restricted and affected our operations and our how we go about our business. That first of all, apparently hand washing is important, which many more people realize now than used to. And also it's given us a greater awareness of how many things we touch during the day, both in our own homes and in public. And so in reaction to that, you know, the industry had already moved toward automatic operators and things like that to assist with accessibility and access in areas like operating rooms and things like that, where being able to move through an opening without holding doors open with your body and that sort of thing. So we're already on that track. But now we're moving from not just automated, but to touchless. So that's where we are now. So again, just as people brought up, building entrances, restrooms especially, healthcare environments, obviously critical. Schools, we all know, educational facilities are places where it's important to limit how things that are being touched. In other situations, office buildings, especially main entries or suite entries when they're multi-tenant places, senior living, multifamily living, especially in those cases for main entries and amenity spaces, all different sorts of places where doors, handles are being touched over and over again every day by multiple people. So touchless systems can be easy to incorporate into an opening. So we talked about main entrances in particular. I think we all know that there are, it's common to have, when you're going into a large facility, to have an automatic operator, at least on one door of a pair of doors, sometimes incorporated with access control also, but typically there is an operator that's already part of the system and part of the access and egress to the building. So we're looking at some components here. This one is the operator itself. This is a low voltage power supply whenever electrified hardware is involved also. And then here is the actuator switch, which in the past was push to open, where you put your hand right on it. And now you can wave your hand in front of it and it will do the same thing from a switching standpoint. So, whoops, wow. My mouse is way too testy today. So again, we're looking at a school entrance, same sorts of things. Typically at the main entry to a school, there are going to be operators that will hold the doors open or make them easy to open, especially during when the kids are dropped off in the morning, and then in the afternoon when they're leaving for the day. It just helps traffic flow. And then during the day, if anyone needs additional assistance, those operators can be used that way. And again, from going from what would have been a push to open switch, we're now changing to a wave switch instead. Hospital entrances, again, same situation. The ADA compliant and a assistive opening is there. And now we can change, essentially we're just changing the switching on it. In addition to these main entrances, there are also some secondary entrances. For instance, at the back of a school, you may have a gym entrance, something in from the playground, perhaps a rear parking lot. In those situations, if the operators are already there, that's perfect. We just need to change the switch out. And if not, it's about adding an operator to it. So that's what we're looking at here, how to build a touchless door system. Obviously, if the opening needs to be, if the opening is a push-pull opening, it would be easy enough from the push side to push on it and get yourself through the opening without putting your hands on it. But if you're on the pull side, it's more complicated. So having the automatic door operator removes that having to come into contact with the door step. And we're showing here again the push to open switch at the top and then the wave switch at the bottom. So the two components are the door operator and then the actuator, which is the switch that signals the operator to engage. Another way to build a touchless door system is with an electric strike, a card reader, and a power supply. So you have a door operator and it's a single opening that latches. You would use the electric strike so that when a valid credential is presented to the card reader, the lip on the electric strike releases and that latch can pass through the strike and the operator can open the door. And in this case, the low voltage power supply is there to provide power to the electric strike and or the credential reader. So it's important to remember here when you're looking at electric strikes or other latching hardware and it's a fire rated opening, it's critical that those openings have to self-close, right? And they have to positively latch if it's a fire rated opening. So in this case, you would need to specify a fail secure electric strike so that when power drops from the opening, that lip is going to remain rigid. So when the door latches, it will stay latched. Okay. Another important thing to remember as far as the operator itself goes is that it's essentially a mechanical door closer that has a motor added to it. And the motor is the piece that requires the power in addition to the circuit boards and all that fun stuff. But If power is dropped to that opening, which if it is a fire rated opening, the door operator also needs to be connected to the fire alarm. If power drops from that operator, it's still going to function as a mechanical closer. So the door is not going to be out of control when power drops. Makes sense? All righty. The other thing I want to mention here while we're on an opening that has a credential reader. So when a reader is at an opening, nobody should go through that opening unless they have a valid credential. In a case where there is a door operator, the credential reader has a couple of things happen when a valid credential is presented. So first of all, it means that the person has access to that opening and can go through it. The second thing is that when that valid credential is accepted, it will enable the switch on the door operator. So the operator will not open unless a valid credential is presented. And that's common for commercial buildings and institutional areas where perhaps during the day, the opening, a reader credential is not necessary, but after hours to gain access, you need the credential. Well, you wouldn't want to be able to use that actuator to open the door if you hadn't presented a credential already. Does that make sense? Okay. So here's a touchless school entrance, taking a little closer look at it. This shows a, whoops, sorry, did it again. So sorry. So this is a what would be a front entry, and a couple of things are happening here. So first of all, there is an operator on the right reverse leaf here. You'll see there's an actuator on the outside and the inside of the opening. In this case, there is a mulligan between the two leaves. So we've got rim exit devices, which is the most secure way for to secure doors in this situation. And two things could be happening here. So in one instance, I think you can see right here on this rail, that's a cylinder dogging function, which means that this push rail could be depressed and the latch retracted mechanically. So when that happens, this opening turns into a push-pull opening. And the operator then can engage whenever somebody waves at the switch on either side of the opening. The other way that this can be accomplished, if this is a secure opening, again, either after hours or perhaps between the time of drop off and pickup during the day, this latch could be retracted using electrified latch retraction instead. So there are a couple of ways to handle it in a non-rated opening, either mechanically through cylinder dogging or electrically through latch retraction, because it's critical for the operator to function that latches are not holding the door and preventing it from opening. This is a situation with a secondary entrance on a school. Again, could be parking lot, gym, something like that. And okay, I just have to stop for 1 second here. I saw this slide and I thought, this is kind of disappointing exterior signage, isn't it? It looks like an after effect. Didn't mean to distract, it just struck me as funny. Anyway, so the latching hardware, because it's an exterior opening, it would be something that you would want to have secure, depending on the occupancy, whether or not this was a storeroom or something like that. It would have either a cylindrical lock set on it, or more typically, it would have a panic device. And you can have a mechanical panic device with a mechanical latch on it in concert with an electric strike. So again, that electric strike is going to release so the latch can pass through and allow the actuator to function and the door operator to push the door open. Okay. And in this particular instance, you probably noticed there is not a card reader there. So that electric strike could be connected to an access control system that allows that switch to be enabled during certain periods of time during the day. Okay, so here is a healthcare application. This one shows a panic device that has QEL is a electronic latch retraction feature, and the RX is our request to exit switch. So as we're exiting the building and depressing the inside rail, the door contact knows that it's not a forced door and overrides the access control alarm situation. From the outside, you present your credential. If it's valid, these the exterior actuator would be enabled, and at the same time, virtually, the latch would be retracted on that panic device, and the operator would be able to open the door. So this would be a case where 120 is coming into, from a wiring perspective, 120 is coming into the operator, and the low voltage power supply is powering the panic device. And this EPT is a power transfer that gets the power that the panic device needs from the frame to the door. So, any questions so far? I'm kind of just chugging right along. Everybody good so far? Okay, so it's poll time again. All right, so what interior door systems can be converted to touchless? A latching door, B, a pair of doors, C, push-pull, or D, all of the above. D, 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 D. Awesome. That is absolutely correct. So all of them can be converted. It's just a matter of how you do it, right? Okay. So just as we talked in the very beginning about different openings that could be, should be touchless, restrooms are a big one. Conference rooms, excuse me, are another one because of the number of people that gather in them. Fitness centers are a huge one. Common areas where people are, more people are gathering from different areas, and cross corridor openings also. So again, touchless solutions not limited to entrances. They can be used all over. Now, I think it's not, I think everybody realizes the fact that going from typical mechanical hardware to going to touchless is not without some cost, without some investment. The question is that investment worth it in regard to operational, both making traffic easier back and forth, and this additional concern about health and transmission of bacteria and viruses. So there are a couple of reasons why that, from a tenant perspective, from a user staff perspectives, all of those different points of view, is this the right thing to do for an opening? All righty, so the first one we're going to look at is an interior non-latching door. Again, the easiest application because there's no latch to overcome. So this would be a push-pull restroom, typically multi-user restroom. Again, you've got a exterior actuator and an interior, both of which are going to be that wave operation. And This is just showing a overhead stop in case that's needed to help control the movement of the door so it can't over travel and damage the operator arm. The automatic operators, again, are mechanical closers with motors built into them, and their arms and components are much more durable typically than standard closers are. However, you can still push on an automatic door, which won't go more than 110 degrees of opening in the first place. But you could push on it and put stress on the gears and cause a problem with it. So an overhead stop can help prevent that from happening if you're not in an opening that a door that swings 90 degrees to an adjacent wall. So that's what that additional component is. Interior latching doors are next, which are more common, obviously. So here's a situation with a cylindrical lock set, again, an electric strike, and then the actuators. So we have a door operator on the door, wave to open actuator, and then the electric strike. So all good. And without the card reader, this would have to be something connected to the access control system for access during certain period times of the day. The cylindrical lock set would have a key override so that you could access the opening after hours. All right. Here is a healthcare application. I think we typically see a lot of this sort of double egress opening. I'm sorry, that one's not double egress. I apologize. Pairs of doors going through corridors, especially from patient areas into treatment areas. This looks like it's on its way to an OR or something similar with those armor plates on the leaves. And you have an automatic operator again. These are the latch retracting exit devices with power transfers. You'll notice on these openings, there are sensors on the leaves, and the operators that we've been talking about up to this point are low energy operators. And low energy operators require a knowing act in order to engage them. In other words, if you were to approach this opening and not engage the actuator, not wave in front of it, you would need to just push through the opening the way you would with a typical mechanical opening. If you want to use the operator, you need to make the knowing act, which is typically to push, but now these days waving for the operator instead. These sensors are helpful in situations like this opening is a double egress opening, just as an additional safety feature to prevent the doors from opening into someone when they're moving through, or closing on them when they're moving through again. High energy operators, which function without a knowing act, have to have safety sensors regardless. But in this case, these sensors are added as a convenience and additional feature for safety. All right, so when we were thinking about adding touchless activity, motion, operation to openings, as you've seen so far, frequently the concern is changing the actuator from a push actuator to a wave actuator. Well, there are times when the operator is going to be added to the opening in the first place. So you're retrofitting the opening to make it automatic opening. In that case, it is not always convenient or possible to put a hardwired actuator on the opening. So what we're looking at here are the transmitter and receiver that would be used for wireless actuators. So the transmitter goes in the actuator, and the receiver would be located in the operator. so that when somebody waves in front of that switch, transmitter sends a signal to the receiver and the operator, and that initiates the movement of the door. These wireless actuators are battery operated. Okay, awesome application for especially block walls, things with delicate finishes. For whatever reason, when you don't have access to provide concealed wiring and you don't want to use wire mold or some surface wiring, great application there. Okay, code considerations, both with mechanical closers and with automatic operators. These are items that are taken out of the box and installed at the opening, and then best practices, the way they should be every time, closers need to be adjusted for opening speed, ease of opening, for closing speed, latch speed, so that the door functions without moving too quickly, too slowly, and that it allows the door to latch properly when a latch is involved. Same thing with automatic operators. There are also ways to adjust the speed at which those openings close. Typically, it's longer than it would be for a mechanical closer, because again, we're usually using them because we want people to have extra time to get through an opening. So there are a number of adjustments that have to be made to mechanical closer. There are more that need to be made to automatic operators. The logic boards that are inside them, dip switches and things like that, make those kind of adjustments easy to do when people read the instructions. Right? Always a challenge to get people to read the instructions. These are some additional code considerations, and these are things that we look at all the time, regardless of the application and the type of hardware. You know, where the hardware is located, 48 inches above the floor for maximum height for operable devices. Kick plates are allowed, and actuator locations themselves are critical. You can't put the actuator in a spot where the door would open into you as you're using that. Frequently with exterior openings, they're either going to be mounted on the facade in some way, or they may also be installed on a bollard, one of those posts that are stepped away from the building. And again, speaking of the wireless actuators we were looking at before, for a retrofit application that requires a bollard, that the use of those battery operated actuators means that the installer doesn't need to drill underneath the concrete pad in order to run conduit out to that post. So if you haven't used wireless things before, it's a great application, something to look into. Signage, doors with automatic operators on them are required to have signage, and this signage package comes as part of the operator. It's not something that needs to be ordered separately. It's part of the operator standard feature. It says that the door is automatic so that people aren't surprised when it moves without cause, seemingly. It needs to be visible from both sides and has to be 6 inches in diameter. And this automatic door caution is the text that should be there. All righty. So the next question is, do we always need to automate doors in the first place? And again, we talked about the fact that automating a door, especially if it has not been automated, but now we are, in order to achieve a touchless operation, costs money, and you need to make evaluate the openings and decide where's that expense most productive, right? Where are you getting the best return on your investment? There are some times when you may want to use a mechanical option instead. And again, what we're looking at here are things that are helpful for push-pull openings. These are not devices that would allow you to overcome a latch, not with a single motion. So this particular piece of hardware up at the top here is something that would be mounted at the bottom of a door, which you could put your toe into. Now, the important thing about these is you'd have to be very careful about where that was mounted so that it didn't conflict with accessibility. So when things like this are delivered to the field, it's important that the installers know where to put them. I think we know we need a 10-inch bottom rail that's clear so that something wouldn't be wheelchair or something wouldn't be snagged on it. So that's one option. This is a plate that would be mounted about push plate or pull plate height, and it allows you to tuck your arm, your forearm or your wrist area inside that curved flange and pull the door open that way. And then this is another piece of hardware that would allow you to, it's an accessory that you could depress a panic bar with. It can help turn a lever. There are a couple of different things that you can do with this particular piece. I have not used one personally, but they are available to help with hardware. The concern would be obviously that it would be something that was available to people when they're at a particular opening. All right, wow, we just plowed right through everybody. So does anybody have any questions either as far as the applications go or situations that you've run into from a design perspective or a code perspective, something like that? What do you think? Everybody good? Any stones we didn't turn over that we should have? What do you think? There's one thing that we didn't discuss about that's not part of this slide, but it's another route that some clients are taking, and that is in respect to alternative surfaces, coatings on hardware. So typically hardware does not have any way to clean itself. It's probably the best way to put it. So there are antimicrobial finishes out in the market, which help with bacteria. And then there are also coatings out in the market, typically with some degree of copper in them, that are not virucidal, but they help to repel. So it's not so much about killing the virus, it's about preventing it, reacting to it at a biological level that prevents it from replicating, which essentially results in it dying, but it's not an immediate kill thing. There's all kinds of discussion, probably about whether or not what is a virus. Truly, is it a living thing? At any rate, there are two coatings that are available: antimicrobial and the copper coatings that help deal with viruses. In addition to the fact that we are talking about washing hands, I think the other thing that has become more of a people have become more aware of is cleaning hardware, and the correct way to do it so that you don't damage the finishes, but you're able to get dirt and debris off of hardware as quickly as you can. And a number of janitorial supply companies are being much more open upfront about formulas and what those different cleaning agents do, where they're suitable to use and how to use them. So that's become another focus and something that we always reinforce. You know, step number one is clean your hands and clean your hardware, and you're already on your way. So I do see a question in the chat box: how to ensure that the wave actuator will not open the door unnecessarily, children or animals playing with it, for example. Okay, so great question. There is a relatively short read distance for the wave. So if children or animals were able to get close to it, we really wouldn't be able to prevent that. But it's not common for wave actuators to be initiating the door operators in cases where it wasn't intentional because of that short read length. I've got another point here about not a good idea to use touchless hardware in public schools for security purposes. So again, if it's an opening that's secure, either there would be personnel monitoring the opening, or it would be one of those situations where you need a credential to, in order to enable the switch to allow the operator to open. But absolutely, there is definitely an additional concern at openings with security. And is this the right thing to do? Yeah, absolutely. Great point. Okay. Anybody else?
I have a question. How much, let's say for a pair of entrance door, how much more would the wave features compare to the regular mechanical actuator?
There is a delta, which I'm not able to share, just because there are multiple manufacturers that make those. It's probably, my guess is like a time and a half, possibly twice as much for those. And again, same thing with those antimicrobial or viral related coatings. It's definitely an investment. However, the idea is that the return, in that multiple people aren't touching them, is worth the investment. So yes, they are more. And the wave actuators, although they've been on the market for 10 years or so anyway, are becoming more common in use. And typically that does mean that after a point, the delta between the two will likely be lower. Yeah, but I can tell you from our standpoint, whenever we're specifying new buildings, I suspect most manufacturers are doing this now, the default selection would be something touchless. Yeah. Okay. Anybody else? Is anybody specified or designed with touchless openings so far? Does any of you have direct experience with it? I know we did have one large multifamily project. The developer was in the middle of construction on one project and still in the design process for the other, and was hoping to retrofit the one that was already in construction. And it frankly became obvious it was going to be too expensive to do it. And in that case, it was related to the fact that they wanted to do the switches hardwired and walls were closed and all of that, in addition to the fact they were going to end up adding operators to some openings. So in that case, it didn't play out. But now their default going forward is to add more operators and to use those wireless switches. So. good
Nicole, we
stuff.
do have a few folks who are noting that they're using it often in the healthcare settings that they're working.
Okay, awesome. Yeah, and that's that is where we're seeing most of the activity. And that, like some other products, high performance sliding doors and things like that, that the healthcare industry tends to be more innovative and reactive in that kind of application. They've always been, right, nurses, doctors, surgeons, everybody. It's a very big concern to be able to move quickly, effectively, and safely through openings to protect as far as being cleanliness goes. So yeah, that's where we're seeing most of that activity. Great, awesome. Okay. Well, I am at the end of my session, and thank you to everybody that's logged on. I truly appreciate it. As I said to Sue ahead of time, she shared the registration information with me, so I have AIA information, and we'll be passing all of that on to our AIA coordinator to make sure that you receive credit for the event. The other piece is that I, as a matter of course, provide PDF participation certificates to everyone and email them to you. And if you need it, that's awesome. If you don't, that's fine too. But that way it's easier for me to send one to everybody than to forget somebody. My contact information has been, was on the initial slide there, and I think you've got access to it through the program invite also. Please feel free to reach out to me anytime. Obviously, we're thrilled when we're able to do specifications for teams, but as a main point of contact, I'm here to answer general questions, provide you with literature, do these sessions also. I do them for firms as individuals, and I love doing it. So I'm always here, whatever you need. So thank you so much to everybody. You've got a few minutes back in your day, an extra little gift there. Have a joyful afternoon, and I hope to meet and see more of you soon. Thank you so much.
Thank you, Nicole. Appreciate it.
Oh, my pleasure. Thanks so much.
See you.